Hi everyone, today I'd like to teach you about inverse functions, and this is a topic which is covered in your Extension 1 as part of your Year 12 Maths syllabus. Now, we've always learnt a lot about functions, which, if you remember, is something which must pass a vertical line test, and now I want to teach you about the inverse of those functions. So, the inverse of a function is exactly as it suggests, which is that it reverses result of that function. So if you remember with a function, what happens is we know the x value of the function, and then from that x value, we use that to find the y value of the function. So if you can imagine, the inverse of the function is just going to be exactly the reverse of that, which is that we go from the y, so we know the y value, and we go backwards, so in reverse, to find out the x value. So essentially what we're doing is we're switching the x and y's. So your x value in your function becomes your y in your inverse, and your y becomes your x in your inverse. Okay, so I want you to keep that concept in mind, that the inverse of a function is just the reverse, literally. Now, the word inverse that we use here, have you noticed how I keep saying the inverse of a function rather than inverse function? And that's because the inverse is actually just a relation. So when a question asks you to find the inverse of a function, it's asking you to find the inverse relation of the function. And why I'm specifying this is because the inverse doesn't necessarily have to be a function, which means that it doesn't have to satisfy the vertical line test. So I want you to know that the inverse of a function, it doesn't have to be a function, because that confuses a lot of people when we get the answer and they think, well, that doesn't look like a function, that wouldn't satisfy the test, so how can that be? Okay, so remember, inverse is a relation, and also what we're doing is literally reversing x and y. Okay, let's have a look at the definition of how we do that. So here we have a set of values within a function, and this, as we know, is our x value, and this is our y value there. Now, can you see that when we find the inverse relation of the set of values, all we're doing is just changing the x to the y. So this x value here becomes the y value there. Can you see that? And this y value here becomes the x value in your inverse. And as you can see, that's exactly what we have here. The 2, which is our x, becomes the y, whereas the 25, which was your y, becomes your x. And you can see that pattern throughout. All we're doing is changing the y to the x and then x to the y. Okay? So I want you to think about it as we're just changing x to y and then y to x, essentially. Now, so this is how we find out the inverse with a set of values. Now I want to go through how we find the inverse of an actual function itself. So here we've been given the function y equals to 2x plus 1. Okay, so to find the inverse, we do what I've been trying to explain, which is we switch the x and the y. So can you see how instead of the y, I've written the x, and where there used to be an x, I've written a y. So I've switched the two. So this here is already our inverse. But because, can you see how the function was given to us with y as a subject? So that's what I want to do now. I want to make y the subject again in our inverse of the function. So I'm just moving the 2y plus 1 to the left-hand side, and we just subtract 1 to the other side, and now just divide both sides by 2, and we get y equals to x minus 1 on 2. And this is the inverse of our function with y as a subject. And when we write the final answer, we write it like this, with this special inverse notation there. So y minus 1 like that is an actual inverse notation. And why I'm specifying this is because I don't want you to think that y negative 1 equals to, it doesn't equal to 1 on y. So what this isn't, it's not y to the power of negative 1, okay? What I want you to think about it as is an actual notation, so that this whole thing represents the inverse notation. So what you're saying to the examiner is, I have found the inverse relation and this is what it equals to. So just don't want you to get confused, because a lot of students, they see this and they think, but that doesn't equal to 1 on y. If I put 1 on y there, that's not what it would equal to. So don't want you to get confused with that. All right, let's go through some questions now. Now we understand the basic idea of what an inverse of the function is. So in question 1, we've been given the set of values in a function and we want to find the inverse of this. So knowing that this is our x value and this is our y value, and knowing that we reverse them in the inverse, what do you think our inverse set of values would look like? So I'll give you a second to think about it. That's great, guys. That's exactly what it'll be. So our y value just becomes our x value, and our x value becomes our y value. So essentially the two just flip for all of these and we get this set of values here. Great. All right, let's have a look at question 2 now. So in question 2, we want to find the inverse of the function y equals to 3x. So remember, the first thing we want to do is switch the y to an x and switch the x to a y. Can you see how we've done that? So by doing that, we have already found the inverse. But now remember how we want to make y the subject, because that's what it looks like up here. So, which means I just move 3y to the left-hand side, divide both sides by 3, and then write y with the inverse notation. So I'm showing the examiner, I know I just found the inverse relation, and that equals to x on 3. So you can see that a lot of the work for your inverse functions is going to be algebraic. Okay, let's try to find the inverse of another function now. So here we want to find the inverse of y equals to x plus 2 on 3. So the first thing we do is, excellent, we want to switch the y for the x, and wherever there's x, we want to write y. And now we just move everything with y to the left-hand side. And with that 3, we just multiply it up here, right? And now we have y plus 2 equals to 3x. So we can just move this 2 over to this side. And then finally, when we have y by itself as a subject, so remember we only want one y on the left-hand side, this is when we write the inverse notation and make it equal to 3x minus 2. And that should be your final answer. Great. Okay, let's have a look at question 4 here. So in question 4, we want to find the inverse of y equals to 3x plus 2 over x minus 3. Now this is a little bit interesting because you can see here that we have two x's, don't we? We have this x here and this x there. So what do you think we do? Well, we do exactly as what we normally would do, which is make the y into an x, and instead of two x's, now I have two y's. Can you see that? So both of my x's, or no matter how many x values I have, I want to switch all of them for y values as I've done here. Okay, so just remember, it doesn't matter if you have 1 or 5 x values, we need to switch all of them for y values. And now we just need to use algebra to make y the subject. So how are we going to do that? Well, the first thing we need to do is we want to make this onto the left-hand side, and we hate working with denominators, so we just multiply that to the other side, yeah? And expanding this, we're going to get xy minus 3x. And now what we want to do is we want to put everything with y on one side and everything else on the other, okay? So pretty much we want to group all the like terms. So in the way, can you see how this has y and this has y? So I want that by itself on one side. So moving that to this side and moving 2 to the other side, I can see now that I can factorize out that y. Can you see that? So I factorize out the y, and that leaves with 3 minus x. And now I just need to divide that over. So I get y equals to negative 2 minus 3x on 3 minus x. You can see I have y by itself now as a subject, and this is when I want to put in the inverse notation. Okay? So the important part of this question is that no matter how many x values you have, we want to switch all of them for y. And then what we need to do is put any values with y in it on one side, factorize out y, and then we can make y the subject as we have done here. Okay, great. Let's move on to the next question now. So in question 5, we want to find the inverse of y equals to x squared. So switching the x and y values, we will get x equals to y squared. So if we still want to make y the subject, so moving y to this side, how do we normally get rid of a squared? Yeah, that's right. We need to square root it, don't we? Now, if we square root x, we always need to add plus and minus, don't we? Now, so inverse of y here equals to plus and minus square root x. Now, this is what I was talking about before. The inverse of a function does not need to be a function itself, because this is not a function, is it? But that's okay, because we're just finding the inverse relation. So I don't want you to get confused and get rid of the negative because you think, oh wait, because this can't be right because it's not a function. Remember, it's okay, we're just finding the inverse relation. So whenever we're square rooting, or we're finding the root of something to an even number, we always have to remember to put plus and minus in front, okay? Because if we don't, we're only answering half the question, and therefore you only get half of the marks as well. All right. So here we go. This is a similar question as well. We want to find the inverse of y equals to x to the power of 6. So switching the two, I get x equals to y to the power of 6. So how do we get rid of the power of 6? Well, we need to root both sides to 6. So we find the 6th root. And remember how I was saying, if you're finding the root of something and if it's even, then we have to add plus and minus, okay? I can't stress this enough because it's just so often that you see students go through so much work and at the end they forget the plus and minus, and you don't want to lose marks for things like that. And if you're going through an exam with a couple of these questions, it's actually quite easy to lose a lot of marks at the end of the day for something as simple as that. All right, so this is, remember, for even, when we're square rooting something or root of something to an even number. So what happens when it's an odd number, as in question 7? We want to find the inverse of y equals to x to the power of 5. So we switch the y for the x and the x for the y, make y the subject, and we need to find the 5th root of that, and that is just positive, because remember, if it's odd root, we only need to write the positive, okay? No plus or minus. So even, plus and minus, odd, we just need to write the plus. So our final answer will just be the inverse of function equals to the 5th root of x. Excellent. All right, well here we want to find the inverse of y equals to the cube root of x. So switching the y for the x and x for the y, and moving y to the left-hand side, how are we going to get rid of a cube root? Well, we're going to need to cube both sides, aren't we? So the inverse of y equals to x cubed. So you can see we're just switching x and y, and we're just using algebra. That's essentially what we're just doing for all these inverse of functions. Okay, so here's something that looks a little bit more complicated. We want to find the inverse of the function of y equals to 2 fifth root of x to the power of 4 plus 4. So as we always do, all we need to do, switch y for x for y. Let's put all of this onto the left-hand side because we want to make y the subject. And we just work through things slowly, okay? Don't get overwhelmed because something looks complicated. Let's just slowly remove things away from the y. What do you think the easiest thing to do first is? Yeah, that's right, the 4. We can move to the other side really easily, can't we? What else? What should we do next? Good, we can divide the 2 across. So now you can see it's a lot simpler, isn't it? And always just move from the outside in. So now I want to get rid of the fifth root, and how I'm going to do that is just by making both sides to the power of 5. So I've gotten rid of that root, this is to the power of 5. And now what do I need to do? I need to get rid of that power of 4, so I make the fourth root of this. Now remember, because the root is an even number, I need to add plus or minus there, okay? You have to add that in your final answer. So we should finally get the inverse of y, so this is our notation, equals to plus and minus, very important, fourth root of all of this. So you can see that even though over here it did look quite complicated, I just want you to think, what can I do? Let's work from the outside in. So the first thing is remove the 4, and the last thing would be to get rid of that power of 4, which you can see is on the most inside. So the best way to go about this, if you ever do get lost, is go outside in. Okay, let's have a look at question 10 now. So in question 10, we want to find the inverse of y equals to x squared minus 4x plus 5. So remember how I said doesn't matter how many x's there are, we need to switch all of them for y. So I've switched both of these x's for y over here, and we have x swapped for y. Now we still need to make y the subject. And how do you think we may go about doing that, considering that we have y squared minus 4y plus 5? What method do you think we can use? That's right, we can use something called completing the square. Do you remember this method? We've learnt this before, but we'll just go through how we do that. So it's called completing the square. Now, let's just move everything with y and the plus 5 to this side. And remember, with completing the square, what we want to do is take half of this middle number and square it. So in this case, half of this will be -2, squared will be 4. So I'm going to change this into y squared minus 4y plus 4 and then plus 1, okay? So I'm separating that plus 5. So now I'll move the plus 1 to this side, and because I have that all on one side, and this I can complete the square, I can factorize that to a square of y minus 2 to the power of 2. Remember how we find that minus 2 is we take half of this, yeah? Equals to x minus 1, and all we need to do now is square root both sides, and please remember the plus and minus, good. And we just need to finally move the 2 to the other side, and see that 2, it has to be outside of the square root. And when you're in a rush for exams, it's really common for students just accidentally write it within the square root. So just make sure you show the examiner it's definitely separate from that. Okay, so finally your inverse should equal plus and minus the square root of x minus 1, and make sure to write it very clearly as plus 2 separately. So remember, when you want to find the inverse of a quadratic function, what we need to do is use a method of completing the square, which was taking half of this middle number and squaring it, adding it on, and then we make y minus half of the middle number squared.